Grandpa, I want to see this one over here.
Okay, but the historical museum's closing soon.
Look at this beautiful model. It's a 1-inch to 50-foot scale representation of our city.
Ma'am, are you in charge of this model? What is it used for?
Yes, I'm just adding some finishing touches. I'm Adriana, Reviva Quito's city planner. The model in the previous exhibit shows the old city of Quito, Ecuador, as it was 100 years ago. I'm making a model of our revived city, Reviva Quito. The model is meant to show Reviva Quito's innovative infrastructure.
We've learned a lot about infrastructure today here at the museum. On the 3rd floor, Grandpa and I learned about energy. Ecuador used to depend on oil for its energy, but then our country converted all the Petroecuador oil wells into enhanced geothermal systems.
That's right. Geothermal is one of our energy sources. Another is integrated solar, which is part of the Living Building Challenge. Did you visit that display on floor 6? That display was meant to show that all of Reviva Quito's buildings are designed to be Living Building Challenge certified. It's the highest known standard of sustainability and includes things like ecologically restorative materials, on-site rainwater harvesting and distribution, and net positive renewable energy. Nature is integrated into our citizens' lifestyles, even in an urban area.
Maddie, did you know there's another special feature that all of our city's buildings have? They all have seismic invisibility cloaks.
Grandpa, you can't fool me. Our buildings don't turn invisible.
No, seismic invisibility cloaks are underneath all buildings. Civil engineers designed the cloaks to reroute seismic waves through concentric rings. See, they're on the model. The cloak stops the buildings from being destroyed by earthquakes. Hey, this is right next to the industrial zone where I used to work as a mechanical engineer on our transportation system.
Grandpa, you helped design the DART?
Ah, yes. We were the first city in the world to implement an all-autonomous aerial vehicle public transportation system. We designed the direct airborne Reviva Quito transit to be pollution-free, easily accessible, and point-to-point. There's the DART shown on the model.
Grandpa, do you remember seeing those automobiles on the 1st floor? You said in the past, people used to travel on roads.
That's right, Maddie. We used to have roads in Quito. With this aerial view, you can see the remains of them. After the DART was finished, the city no longer needed roads, so the city planner transformed them into bike paths, aquaponic gardens, and feature parks. It was all part of the general plan.
I learned about the general plan in my history class. In 2016, Quito hosted the United Nations Habitat 3 conference. Quito city planners learned all about housing and sustainable urban development.
Afterward, they drafted the general plan, which set goals for housing, transportation, energy, and most importantly, our network of public spaces. They made a plan to rethink, redesign, and revive Quito.
My uncle, Evan, attended Habitat 3. He told me the problems Quito used to have. Crime, poverty, food insecurity. Citizens of the slums didn't have basic necessities, let alone places to play, relax, learn, and socialize.
Right. These are the problems that the city planners addressed when redesigning the city. Their public space solution was repurposing to revitalize, or R2R.
Oh yeah, I see it on your presentation board. R2R had 2 parts, roadways and brownfields.
R2R roadways were designed to be walkable, with pedestrian and bike paths, aquaponic gardens, and interactive feature parks, which are located at old intersections. My favorite are the live entertainment and the 8 to 80 playgrounds for old folks like me.
I can see the rock climbing wall in the virtual reality feature park that I went to with my friend Sarah yesterday. I can also see the outdoor dining areas, aquaponic gardens, and Reviva vendors on your model. I love ordering fresh strawberries. It's neat watching the agrobots harvest only the ripe ones.
My favorite part of the R2R roadways is being able to bike home after work. The pathways glow in the dark. I also like the solar canopies, which allow me to ride to work even in the rain. It's just like the cyclist here on our model.
Wait a second. Why does that label say converted brownfield? That's the STEM Center.
The STEM Center was built on an abandoned Petroecuador fuel terminal. Environmental engineers decided to clean up this site. Assessments showed that the soil and groundwater were contaminated. Microbial degradation and phytoremediation were used to clean up the land.
Oh, the footprint of the brownfield must have made it an ideal location for my favorite feature park. At the STEM Center, I dream, design, and build projects with real-world applications and augmented reality.
Maddie, do they teach you about the engineering design process when you're at the STEM Center?
Oh, yes. I used it when designing my first robot. First, I learned the specifications, brainstormed, and then started designing a prototype. But when I first tested it, it didn't work as I planned. So I redesigned it, improved it, and then tested it again. I was so excited when it finally worked. Do you think the designers of R2R use the engineering design process like I did with my robot?
Of course, chemical engineers had to design and redesign a system that would automatically regulate the chemical balance of the aquaponic gardens.
The designers of R2R also had to assess the multiple risks and trade-offs. The biggest trade-off was funding, but the Inter-American Development Bank granted Quito money that was earmarked specifically for R2R.
A risk of R2R is park system management. So information technology engineers designed automatic systems to collect data about park usage through embedded IoT sensors.
R2R was a terrific idea. I'm glad we don't have any old-fashioned roads or that polluted brownfield anymore. Fresh food, feature parks, and the STEM Center are so much better.
Maddie, now that you've learned how many engineers it takes to build a city, don't you want to be an engineer?
Are we on? Yeah, the mic's on. Go first.
First problem, yes. Well, your challenge was public spaces. I would like to ask you guys what compromises you had to do to design your city while achieving this main goal to have solved the challenge of public spaces in the city.
One way that we really integrated the challenge was that we realized that public spaces are very helpful to citizens. We want to give these citizens a very biophilic environment to live in and incorporate nature in their regular lifestyle. And so that's why when we were setting it all up, we wanted to have these feature parks in the aquaponic gardens very close by to the multi-use buildings, so that way they can just walk right out, get their fresh food, and then sit in a nice biophilic environment.
One of the compromises that we realized was funding. And we had to think about a way to get that original funding so that we could then get the return on investment from our solution. And we learned about the Inter-American Development Bank and how they grant money for Latin America for social problems. And we were really excited so that we could start implementing our design and get the return on investment so that we could continue enhancing the lifestyle of our citizens.
Another risk that we had to deal with was definitely our polluted brownfield. Since we knew that we wanted to place our STEM center on top of it, we had to deal with the risk of what if it isn't properly cleaned up? We're placing kids in this environment. So that's where our environmental engineers actually helped. They helped us conduct multiple environmental assessments to make sure that that brownfield was totally cleaned up and safe.
You mentioned earlier that you take probably 6 months, 4 months to develop the idea and 2 months to build the model. And when you kind of start building a model and the model evolve, have you made any changes? And how is the change eventually impact your original goal, original idea?
One of the things that we were originally planning on was having a scale of 1 inch to 100. And when designing the terrain of our model, when building our model, we were making this mountain in the top left corner. And we realized, and our engineer mentor helped us realize that what we had right there, if our scale was 1 inch to 100, we'd have too many cliffs and it wouldn't be the rolling hills that Quito has today and that we wanted. So we had to then make a compromise for that and change it down to 1 inch to 50.
Another thing that we learned is Jeremy, whenever he originally our DART design is that it goes through the middle of the buildings. It's very convenient for our citizens. And something that he originally started out trying to do was like drill holes through Mentos cans because we wanted to really show that it went straight through the buildings. But we ran into a problem with friction because whenever we went to turn the DART, it wouldn't go through that hole. So we had to compromise and make it like it is now.
I do have another question that you use cable car to transport people from one section or one zone to the other zone. Is that enough actually transport? How big is the city you're building for? If you have 10,000 people or 20,000 people, is it enough for a cable car to transport people from one location to the other location?
So our transportation is actually flying. The fishing wire is there to show that it's suspended in the air. And how it works is you have it coming through, like let's say during rush hour, your drones will then come in and then they leave. And then for traffic purposes, they'll use virtual corridors and can travel at different altitudes. so that you can transport the 4.4 million people in our city throughout the city.
Give us an example of something that you learned about engineering that surprised you during the process.
One thing that surprised me is that we actually went to go talk to the Gilbert city planner in Arizona. And she talked all about how to be able to work on a team. And like you all have an idea that you want, but you have to be able to work together to actually implement it into it to make a great city. Like the IT engineers, they had to help make the IoT sensors. So that way we would be able to have this city that is running by the data analytics that can constantly make the parks better. And then our civil engineers had to ensure safety through earthquakes.
Something that surprised me is how much it's a blend of reality and futuristicness. So how much it's a blend of taking current technologies and projecting them into the future versus dreaming up new ideas, but still making sure that those ideas are feasible and reality-based.
What industries did you actually think your revitalized Quito were going to grow into in that city that you designed?
One of the industries that is part of Quito today and that we wanted to continue in Riva Quito in the future is the historical district. So it's a large tourism site, not for like a beach or terrain or anything, but because of their historical sites and the great history that it has. So we wanted to make sure that we could preserve that in the future by using our carbon fiber wraps to add support to their structural beams, because Quito gets a lot of earthquakes, that'd be able to renovate the buildings and make sure that they're still standing in the future.
How we provide funding for our municipal services in our city is mainly through our high-tech industrial. Some of the industries listed here on our model include our Agribot, which manufactures our autonomous food harvester, our autonomous aerial vehicle manufacturing headquarters. It not only repairs, but manufactures new darts. And our Experience Ed, which writes the augmented reality programs for the STEM Center, as well as for our historical feature parks.